So today I'm going to be discussing DC Circuit 6, putting it all together, and I'm going to be particularly looking at problem 6.4. The problem says a battery potential difference delta V equals 10 volts when the circuit is connected to the following circuit. All resistors are known values of R. R equals 10 ohms. Find the following. So we want to find A through F, and there are several values that we need to find within this problem, but we have to use this particular picture or circuit in order to help us find it. Now, just to establish a pattern, we know that R4 and R5 are a parallel circuit, and we know that R2 and R3 are a series circuit, and they're all within one parallel circuit to each other. So knowing that, that will help us find REQ. So R4 and R5 is this right here. And knowing that they are parallel to each other, we have to take 1 over 10 plus 1 over 10, and 10 value comes from here, yields 2 over 10, but we have to take the reciprocal of that, so that gives us 5 over 10. 5 ohms. Now, knowing that R7 and R6 are 10 ohms, we leave it be, and we look at R2 and R3. Since R2 and R3 are in a series circuit, we just simply add the values, 10 plus 10, to get 20 ohms, and that would be our ohms for that. Now we have to look at the giant parallel circuit, and within this circuit we have to add the number of ohms together. So this is 5 ohms, this is 10 ohms, and this is 10 ohms. So that would be 1 over 25, considering that it's a parallel circuit, and we would add it to 1 over 20, which is 10 plus 10, which is 20, and 1 over 20. Then we're able to get the value 9 over 100, and we take the reciprocal and we get 100 over 9 ohms. Now we have to remember, we have to consider R1, which is just 10 ohms, and add the values together to make sure we don't neglect that particular resistor, and we get 21.11 ohms. So that's the answer for part A. For part B, we want to find the total current at this place right here. So we know that the equation is I total equals 1 over R times delta V. And we've already calculated the resistance from the last problem, and we know delta V because they gave it to us in the problem. So all we have to do is plug it in and find total number of amperes, which is 0.47. In the next part, which is part C, we want to find I2. And I2 is right here. That's where the ammeter is, so that's where we have to calculate I2. And since it's within this region, we want to look at R2 and R3, and the resistance there is 11.11, like we've calculated in part A. So we use that value, so it's 1 over 11.11. And we want to find the delta V at that region too. So what we want to do is we want to subtract the total delta V from the delta V at this region. That would be 1 over 10, because the resistance there is 10 ohms, and we know the I value, which we calculated from the last problem, 0.47. And we plug that in and we find delta V there. And we subtract it because we want to find for the other region where the current is, right here. And when we do that, we just calculate it out again, and we're able to get 0.265 amps. And that would be the current for that particular region. Now, for part D, we want to find I3. Now, knowing that I total is 0.47 and I2 is 0.265 amps, and we've calculated that for part B and part C, we simply have to just subtract the values to find I3. Then, for the last part, we have to find the delta V values. So we want to look at delta V1, which is right here, and delta V2. It's a similar approach for both problems, and basically we have to just plug in values that we know and solve for delta V. So over here, 0.47 was the value that we've calculated from part B, which is I total, and that's at that particular region, so it works. And 1 over 10 because the resistor there is 10 amps, which is right here. So you plug in those values and you solve for delta V and you get 4.7 volts. Now we want to find the delta V for the second place, which is at delta V2, and we find it in the problem, which is right here. And again, we know what the resistance is. It's 10 because right here R7 is 10. So we plug in that value and we know that 0.205 is the number of amps because we calculated that in part D. So knowing that, we just have to plug it all in and solve for delta V, and we get our value of 2.05 volts. This is the explanation for 6.4, putting it all together. Thank you.